Let us revise the previous chapter which we have learned before. Is for flexible pavement. For flexible pavement, there is four types of layer. This is surface course, base course, sub base course, subgrade. IRC 372012 so steps about flexible pavement. How to define the strength of the subgrade. Define the strength of subgrade. CBR test, triaxial test, plate bearing test, California resistance value test. Basic purpose. What are the basic purpose? What are the basic purpose of subgrade? Prevent pumping against frost action. wearing coats, and for wearing coats it gives the impermeability. There are two types of pressure. Pressure contact pressure and tire pressure. Contact pressure is load on wheel divided by area. Suppose this is the tire. This is the tire pressure and this is the contact pressure. If tire pressure is greater than contact pressure, then contact pressure divided by tire pressure less than 1. So tire pressure, tire is in tension. If contact pressure, tire pressure greater than 1, then contact pressure greater than tire pressure. So tire is in compression. So so rigidity factor, rigidity factor is equal to contact pressure divided by tire pressure. If contact pressure less than tire pressure, rigidity factor less than 1, contact pressure greater than tire pressure, rigidity factor greater than 1. So, to calculate heavy vehicles, those are consist of multiple axles. For simplify the mathematical calculation, we have to equate those multiple axes into an equivalent single axle, and for this reason there is a concept of equivalent standard wheel load. Equivalent standard wheel load has come into places. Suppose what is called axle. Axle. Suppose this is a truck or a car. So this is the wheel. So this is the wheels, and this is the rod. And the whole system is called axle. Now come to the standard single axle wheel concept. Suppose this is a wheel and this is also a wheel, they are connected by an, so this is an axle, these are the wheels, and this is the road surface. So how can we distribute the load to the road surface? By this way. Okay, so this part is similar. This is only the single wheel part, the wheel 1 part, pressure due to wheel 1, and this part only. and pressure due to will to. This part only. But in this case, both pressure is overlapped part. How to calculate this pressure? So to calculate this part, let us again draw the single wheel, the single axle, and the load is distributed in a 45-degree way. So at a d by 2 depth, at d by 2 depth, at d by 2 depth, ESW will is equal to P, because why? Because no overlapping happened. But for depth greater than 2s, we can say ESWL equal to 2P. So between this part, now get a fresh page. And let us again draw the diagram. So up to d by 2 depth, up to d by 2 depth, this is P, and beyond 2 is the pressure is 2P. So to calculate any pressure at a particular j depth, we have to interpolate between them. And What is the axial dimension? This is D. That means D means outer face distance. S is distance between the center of wheels and the tire is 2a. The tire dimension is 2a. So, so S equal to D plus A plus A. So D plus 2A. So from this page we can come to the solution S equal to D plus 2A. Now put a similar graph. What we have said, at D by 2 depth the pressure is P. That means this point is D by 2 comma P, and at 2s depth the pressure is 2P. The pressure is 2s comma 2P, this point. So we can draw a straight line. My line is never straight. This is actually a straight line. So this point is D by 2 comma P, and this point is 2s comma 2P. So at any depth Z1 we can easily determine the pressure at this point by interpolation, and I have forgot to say the ESWL is in log scale, and this is in also log scale. And we have said previously, we have mentioned the depth as z. So suppose this point is dy 2 comma p, that means x1 comma y1, x1 is equal to dy 2, y1 is equal to p, x3 y3 is equal to 2s 2p, then x2 is equal to z1, y2 is equal to what? So this point is 2s 2p, then z1 is equal to, so the slope between, that means log, the basic formula is y2 minus y1 divided by x2 minus x1 equal to y minus y1 divided by x minus x1. So here, according to this, we can say log 2p minus log p divided by log 2s minus log dy 2 equal to y minus log p divided by x means z1 minus log dy 2. Log dy 2. So basically log 2p by p divided by log 2s divided by dy 2 equal to y minus log p divided by z1 log z1 log dy 2. So log p, log 2 divided by so log 2p by p divided by log s divided by d by 2 equal to log y by p divided by so the final formula will be log 10 so we can clearly match them. Let us check log 2 divided by log 2s by d equal to log y by p log 2z1 by d. So let us try to solve a problem. Suppose this is a dual wheel assembly carrying P. Each wheel for, apply a force of 20,440 Newton. 20,440 Newton. And what we have said previously, the S is equal to, the S is equal to 27 centimeter, and the D is equal to 11 centimeter, and the tire dimension 2A is not given, not given. So according to the we go to the fundamental formula. This is the dual wheel assembly. What is D by 2? D by 2 means 11 by 2 equal to 5.5 centimeter, and 2S is equal to 2 into 27 centimeter. So at Z equal to D by 2 equal to 5.5 centimeter, the pressure is P3 is P equal to 20,440 Newton, and at Z equal to 2S, that means 54 centimeter. At it, by mistake I have written P3. P3 is equal to 2P, that means 2 into 20,440 Newton, that means 40,480 Newton. So this this point is 5.5 centimeter and 440 Newton, and this point is 54 centimeter and 40,488 Newton. So we go to the basic formula. Log 10 ESWL is equal to log 10 2P minus log 10 P divided by log 10 2S minus log 10 D by 2. That means log 10 400 and minus log 10 . So we have to calculate the equivalent standard angle at Z is equal to 20 centimeter. So Z Z2, we can say Z2, Z1 is previously given 5.5 centimeter and Z3 is given 54 centimeter. So this point is, and this point, the both point 5.5 centimeter and Newton. Log P divided by log 2s log d by 2 into log 20 minus log 5.5, that means log 40,880 minus log 20,040 divided by log 54 minus 5.5 into log 20 minus log 5.5. So the P we have got is equal to 30,242.5 Newton.